I'm Michelle Selvins, and I've been here at the Air and Space Museum for a year doing a postdoc, and before that I was at California Institute of Technology doing my graduate work. So I got my PhD there, and before that was at University of Boulder, actually, and that's where I first started doing planetary science research. Probably a story almost everybody in this building would give you, whether they're a fellow or an intern or a staff member or security or anything, is they remember it from being a kid and it was an awesome place to come. And so that was always there in the back of my head, and I knew going through grad school that I liked teaching a lot and that I really wanted to do a lot of outreach, and those aren't things that are necessarily part of a postdoc. Postdocs are usually very focused on research, and so I kind of had in the back of my mind, okay, there are these cool museums out there that are places I'd like to be to do research or do outreach, and it turns out there's also a research department here, which as a kid I never knew. So far in the last year, what I've started looking at in terms of research is mostly on Mercury. So we have an orbiter at Mercury right now called MESSENGER, which is a big long acronym, but part of what it's looking at is surface tectonics, so faults that cut through the surface. And there's different ways we've taken pictures, mostly so that you can look at dawn and dusk kind of settings, so you have really long shadows, and you can use those shadows to figure out where all these features are and what patterns they're in and how big they are and if they're connected to each other and stuff like that. So what I've been doing is looking at a particular part of the surface that's like a lowlands area near the equator. It's kind of got a special setup, but it's got all these faults that are really close to each other, which is unusual on Mercury. We kind of have that on Earth, where you have plate boundaries. You'll have like a bunch of faults in California or something like that that are all next to each other, but we don't really understand why that happens on Mercury because it doesn't have plate tectonics. So I've been mapping those and starting to model them. The other thing, which actually a summer intern came in and helped me with this summer, which is a really cool experience, is looking at the ice at the North Pole of Mars. And so there's this big edifice of ice that is mostly water ice, so it's like our polar caps here. And actually the one at the North Pole is like the size of the Greenland ice cap. So it's pretty sizable, pretty thick, and it's got layers in it like we have on Earth, which is kind of cool. On Earth we know there are like annual layers that get deposited, and you can take an ice core at Greenland and you can see all these layers. But on Mars, the only way we can look at it was with radar data. So the radar can see through the ice and it bounces off all those layers on the inside. And so you get a picture of the inside of the ice and what all the layers look like and what they're doing. And so I've been mapping out some of those layers to try to understand what the oldest ice looks like, which would be maybe 600 million years old, or maybe even as much as 2 billion years old, which is way older than any ice record we have on Earth. And if those layers are preserving a climate history like we have preserved here on Earth, we could potentially, you know, in maybe 50 years when we have the technology there to do this, or we have, you know, people we've sent there as astronauts to run the drill rigs or something, we could actually get an ice core and understand a climate history of a whole other planet. The way you know when something is ready to be published is a little different. And, you know, hopefully over, say, 3 years, I would publish 2, 3, 4 different projects. And they might all be related, right? They might all be on Mercury, or they might, half of them be on Mercury, half be on Mars or something. But that's a little more nebulous, knowing when it's time to publish something. Because you can always keep going, right? You can always spend a little bit more time and figure out this one last little detail, but at some point it's more important to get your work out there so other people have access to it and know what the results are than it is to get that one last little detail. Some really great researchers here, which is probably going to be true in most universities you're at or research institutes or whatever, but there's a real mission focus in this department, so almost all the permanent faculty are on different planetary missions, which means they have access to the data first, and they're part of the planning team that collects the data and gets to formulate the questions we ask, and that means that I get to work on the MESSENGER data, which is kind of cool because that's coming back right now. You know, every day there's new images I can download and look at. and analyze.
Right.
Getting to actually get your hands on the data and then see what it tells you is a lot of fun. I think that's my favorite part of science. So that is a huge benefit of being here, is a lot of mission involvement and really excellent people to talk to. I think it's a great place to learn both how to be a better researcher and how to be a better advocate for science and sort of educator for the public, which is a really important part of any career, right? But it's a really important part of science, is to be able to communicate what's exciting and why it's relevant and everything. So yeah, I think it's a very unique, wonderful place to be, to do a fellowship.